the purpose of redistribution and examples of redistribution and some rules that are related with redistribution between two different routing protocols. So now we come to the next important protocol, especially for network monitoring teams. In some large organizations, especially the ISPs, there will be a separate department or team of engineers called monitoring team. And their main function or job requirement is to monitor the network. Suppose if you say Airtel, it's a countrywide network, or BSNL is a countrywide network, or Railtel Corporation, yes, it's also a national ISP, right? So when you have such a big network, you need to monitor that, how the equipment are functioning, how the links are utilized, whether the link is up or down, or if it is up, the utilization is happening properly or not, whether the device is working properly or not, whether the servers are working properly or not, or is there any issue in the servers. So we have an important protocol for managing the networks or monitoring the networks called SNMP. This is a protocol. SNMP is a protocol. It stands for Simple Network the name itself says Network Management Protocol. SNMP. This protocol, we will be discussing in detail about this protocol. So its main function, why we need to know about this or learn about this, is for monitoring the networks. It can monitor routers, it can monitor switches, it can monitor firewalls, it can monitor Wi-Fi equipment, it can monitor desktops, PCs, desktops, servers also. Okay. So it is an internet standard protocol, also called open standard protocol, mainly for collecting and organizing information about managed devices. So the term managed device means any device which we can assign IP address and manage, that is called as managed device on IP networks, for modifying that information to change device behavior. So apart from what I mentioned, for monitoring, this protocol also helps administrators or network engineers to configure the protocol based on the need. When sitting in Hyderabad, without using Telnet, without using PuTTY or SSH protocols, we can also configure the remote devices with SNMP protocol. So not only it helps in network monitoring purpose, it also helps in configuration purpose, modifying the configuration, modifying the information on the network device to change its behavior. So typically, this protocol is included when you buy a router or a switch or a Wi-Fi. It comes with SNMP protocol available in the device. Even printers, network printers, scanners, every network device can be managed if it supports SNMP protocol. Previously, a few years ago, only certain devices used to be managed devices, but all IT infrastructure can be managed through SNMP. Smart buildings, you must have heard about smart buildings. Means you are giving intelligence to the building. So even they are the BMS, building management systems, like elevators, electricity, air conditioning. So everything is now SNMP enabled. IoTs, so they also have this SNMP protocol enabled on those devices. So it is an open, widely accepted protocols to manage, monitor network components, network devices, network elements. And it is on the most professional grade because it's been there for so long. See, anything that has been there for so long, what happens over a period, it gets improvised and gets better and becomes a very good product. So SNMP is a very important, I can say, critical protocol for organizations like ISPs, service providers, etc. Because network is their business. So if you want your business to run properly, you have to have a good network monitoring. So this product, the application product used for this network is called as NMS. Network Management System, NMS. Like we call browser browser is, there are different types of browsers. So similarly, for network management, it's called NMS, and SNMP is a key protocol in that NMS. So like different applications use different port numbers. Like I want to connect to a web server. If I want to connect to a web server on using a browser, I have to use HTTP protocol. So HTTP protocol runs on certain port. Web server runs on some port, like IP address we give to a network device. Similarly, on that particular device, on that particular server, we can run multiple services like DNS, FTP, so many things we can run, so many services we can run, so many applications we can run. So SNMP also similarly uses port number 161 and 162. Like how web servers use port number 80 by default. We can change that port to 8080 or 8383 or whatever number, but by default it runs on port number 8. So similarly, SNMP uses port number 161 and 162. Why we are mentioning this is suppose in your company you are using some firewalls, and that firewalls used to block unwanted traffic. And most of the time, all ports are blocked by default. Suppose you want to allow, then you have to tell the firewall, please allow this port number 80 or port number 21 or port number 23. Suppose you are using NMS, then you have to configure in the firewall to allow port number 161 and 162. So when you use security, we have to be very careful to open only those ports that are required by the organization. And if you are using SNMP or NMS tools, then we must allow port number 161 and 162.
Can you explain this trap and?
I'm coming. We will be discussing in detail about this in a little while discussing about the functionality of the protocol. Just to say that this port number 162 is used for this purpose. Suppose something happens to the device, and this device has to inform the server that, hey, I have a problem. So then it is using port number 162, just for that reference purpose, but we're going to discuss about the trap and inform also now. So what are the components? What are the components? SNMP is a protocol, but this protocol to use, so HTTP is a protocol. How are we using the HTTP protocol? We are using a browser. Through the browser, we are specifying HTTP : that domain name. So we have a browser, but just having a browser is not enough. You must have a server, web server. Web server will be run on a Windows server or a Linux server, but that is not enough. You need Apache web server or IIS web server or Tomcat. These are the components. To run one web application, you need a server, you need a client. So similarly, to run NMS, we have SNMP manager, manage devices, agent, and MIB. These components are required for this protocol. So these are different applications like SNMP manager. NMS is nothing but SNMP manager. NMS, we just mentioned this earlier. The server software required for managing the network is NMS. So we call manage SNMP manager or NMS. Manage devices or PC, server, network, components. SNMP agent is a software which resides on the router, on the switch, on the firewall, on the load balancer, on the Wi-Fi device, on the IoT device. And this database is also a software component which is inside the agent. MIB will be inside the agent. So what are the components and how and where they are used and how this protocol actually works, we will discuss. So starting with the first component called manager, NMS. So you must have known about, suppose if you are already there in the networks, maybe your company or organization is using some network manager tools like SolarWinds, like HP, OpenView, or Cisco has their own components, like IBM has their own components. So there are different applications available. Manage Engine, there's one company called Manage Engine. They also have network monitoring tools. Okay, so SolarWinds is popular, Manage Engine is getting popular, but this IBM, HP, they are all very expensive products. They are good, definitely they are good, and they are expensive. used for enterprise organizations. So SNMP manager or management system is a separate entity that is responsible to communicate with the agent. Basically, agent means client. Let us differentiate with the terminology we are aware of. SNMP agent is like a client. SNMP manager is server. So how to differentiate is SNMP manager means server, SNMP agent means client. Okay. Implemented on network devices. This is typically a computer that is used. Which is the typically a computer? SNMP server is a computer that is used to run one or more network management systems. Use network management system. I can run multiple tools. SNMP manager or NMS can be one of them. So server, SNMP manager is a server. So SNMP manages functions. What does it do? What are the key functions of the manager? It queries agent, means sending the request to the agent. Hey, tell me what about the status? The server, SNMP server is asking the agent, hey, please tell me what is the status of your memory? What is the status of your link? What is the status of the bandwidth utilization? What is the status of your CPU utilization? So it can send queries. SNMP manager can ask queries to the agents. Definitely, if you're asking a query, agent should respond. So gets response from the agent. You're asking a query to the agent, agent is sending the reply, response. Also, we mentioned earlier, we can configure the network device. Suppose I want to change some parameter on the router or change some parameter on the switch. So you can set variables in the agent using the server SNMP manager. I can set some variables. I can configure the agent by setting the variables. It could be assigning an IP address. It could be shutting down one interface or enabling one interface. These are some parameters that we can do. We cannot do everything, like whatever you do using a console or using a telnet on the router. You cannot do everything using the SNMP. You have some limitations. You have certain specific variables that you can deploy on the remote devices like routers, switches, firewalls, etc. Apart from these, finally, it sends acknowledgements to the events from the agent. Suppose if the agent says, hey, my link is down. So the server says, okay, got you. I received your message. Okay. So these are the key functions of the SNMP manager. And then manage device. This is the second component of the SNMP. Manage device, as I mentioned, it is a network element, network device. It could be router, it could be switch, it could be server, Windows server, Linux server. It could be workstation like Windows 10, Windows 8, whatever. Firewalls, Wi-Fi devices, printers, even UPS, building management system, as I mentioned earlier, IoT. They are also common to the managed devices. A managed device means which has SNMP agent software. So we don't have to install it separately. It is already available. Maybe let me check if I can show you. Normally it comes actually. SNMP we can see technically. Okay, maybe you can check on your system if maybe it is available on the network properties, SNMP. Okay, just wanted to show if it is available. So agents come with the SNMP client. So it's a program that is packaged within the network element. Enabling the agent allows to collect management information locally. So it could be link status, as I mentioned. It could be CPU utilization. Suppose you are running a huge server. Millions of users are accessing that server, like Google, etc. So the administrator should know the utilization, CPU utilization, memory utilization. So how they will do? They will enable SNMP, and they have a dashboard where they can see CPU utilization is 50%. Like we go to, we have this. Let me just show you. Task manager. So what does the task manager show us? It shows utilization, CPU utilization on that local system. But if you want to see the remote system, you want to observe on the remote system, how we can see? Can we see? We cannot see. So using the SNMP, we can observe the remote devices utilization, network utilization, CPU utilization, RAM utilization, etc. So SNMP agents key functions: collect management information, store and retrieve information. The database is called management information base, MIB. Signals an event to the manager. Suppose something happens, link is down. So this has to be communicated to the server. So it is the agent's functionality. And it can also act as a proxy for non-SNMP manageable network nodes. There are some special cases. Okay. So server, client, and agent software. So whatever we have discussed, SNMP manager is a server we call NMS. So you can see the messages that come are, trap message, inform message, and management definition. So you can see it can, what can SNMP manager do? It can know what is happening on the managed device, and it also has a facility to configure some of these components. What it can do, it can set some parameters on the server, on the router, on the switch, maybe on the desktop, Wi-Fi, etc. also. Remember, all these we call as agents. All these are called as SNMP agents. SNMP server is the software that is configured on a computer or server. Agent is the users, not actually users, it is the devices, network devices like router, switch, firewall, Wi-Fi, etc. So anything happens to this router link, then this will trigger to send the SNMP trap information. Remember, somebody asked me what is a trap. So basically, trap is a message sent from the device, network device, to the manager saying that my link is down. Okay. So just you can see this is the trap message, how it works. So we have this SNMP server in the network. Sometimes it can be in a centralized headquarters. Suppose this agent is in the branch office and something happened to this agent and it is sending this message, trap message to the NMS. So in that message, details about this agent will be present, saying I am so and so, this is my device name, I am sending this information. So because every agent will have its own database, the database on the router will be different from the database on the Windows 10 computer, and will be different on the Windows Server operating system, or on the switch, or on the firewall. The database will be different. Because you will not be directly connecting, you will be connecting via the switch, but we are just showing you the pathway. Basically, if this is in a branch office, how the branch office will send to the head office? The PC will be connected to the switch, and this switch in turn will be connected to the router, and this router in turn will be connected to the WAN link, MPLS or WAN link, and through that it will go to the headquarters. In headquarters also what will happen? You will have a router, and this router will be connected to the switch, and that switch in turn will be connected to the NMS server. Okay, so you get the picture. So trap messages are generated by the agents. The source is the client or agent, source, agent, and destination is NMS server. The way this SNMP protocols work. Then we have inform message. Information. Suppose my hard disk is getting full. The user machine's hard disk is getting full. So you need to send an inform message. Inform messages are sent. Again, source is agent. Destination is the NMS server. Now, this is a different message. Get message means get. I want the, not I, means the server will send a request saying, hey, tell me what is the status on your link. So this is generated. Source now is NMS server. Destination is the agent. So it will send a response. It will send a response saying, hey, you asked me these details. I'm providing you these details. Okay, so these are the various internal messages within the SNMP protocol. One is a trap sent by the agent to the server. Other is the inform sent by agent to server. And get or get next, get bulk, set. Set is to configure. I want to change the IP address on the switch interface, or I want to change the IP address on the router interface. So set is to configure the new parameters. Or I want to disable one port on the switch, or I want to disable one port on the router. We can use this set parameter with the SNMP on the. Okay. So any questions so far?
This SNMP we can configure on our own, or we need to buy some third-party software?
Sir, we have to buy third-party software, sir. But there are some free versions available on Linux, something called Nagios. There is a network monitoring called Nagios on Linux.
Okay.
You can download the tool, enable SNMP on the router switch, and configure that Nagios on a Linux server. We can do that. There are many organizations. There is a commercial version of Nagios also available.
Okay.
Yeah, so we can use, or we have to buy tools like SolarWinds, Manage Engine. They have tools license based where there is provides. The difference, as you already may be aware, the difference between open source tools and licensed tools is open source tools are free, but support is not very easy to get. Whereas commercial tools are expensive, but support is easy, because when you buy something, they will give you support anyway.
Yeah, true. But open source are equally as reliable as.
They are. Nagios is being used by many organizations. Yes.
Okay. Thank you.
It is a stable product. Yeah. Okay. So I have one question. SNMP is enabled control panel programs, add Windows features. Okay. Thank you. Yeah. Previously, it was available in network properties actually. Okay. Thanks for that. Okay, so these are the components of this thing. And now coming to the versions are, like initially when SNMP was introduced way back in the early 90s or so, it came with a version 1. It has very limited functionality, limited features actually. It was not so popular later on. Even today, nobody uses SNMP version 1. Even version 2, very rarely they use. Okay, because they have been revised with added features and functionality. Okay, so you can see the RFC, request for comments. Basically, when you see the term RFC, means it is open standard. Whenever you come across a term called RFC, means it is open standard. So SNMP version 2 is enhanced version of version 1, where different types support MIB structure, community based. But both in version 1 and version 2, security is not available. SNMP version 1 and security is not available. Girishji, it is default for most organizations unless the organizations do not want to use the open ports. It is again organization specific. Vendors, mostly they follow the open standards, but maybe they give provision to change. Yeah. Then coming to version 3, which is very stable and reliable. I don't mean version 2 is not stable. Version 2 is very widely used. Version 3 add-on is it provides security. I don't know if it's been mentioned here. Most importantly, maybe it's defined here in the RFCs, because there are so many RFCs for SNMP version 3, if you remember here, when compared with version 1 and version 2, there are more RFC codes for version 3. One of that could be for security. So you can encrypt the data. You can encrypt the SNMP messages before sending it out onto the network. So this is about the SNMP. So any questions so far? Mostly it is related with network monitoring. You have a desktop network monitoring teams. What they do is they have a graphical view of the whole organization. The links are in green if they are working. The moment the link goes down, trap message will be sent, or even this server can be set to send messages asking, give me the status. You can set the frequency every 5 minutes, every 10 minutes, every half an hour, every 1 hour can be defined in the server.
Sir, is public community, private community some technology?
This is related with the configuration. Yes. Yes. If you want to ensure that your information stays private in the sense, don't want to allow outsiders to control. You may ask, what do we mean by outsiders to control? Let me take an example. There is a multinational organization, big one. Globally, they have offices. In India also, they have some 100 offices, let us say. So what they do is they outsource their network monitoring or network configuration. How do I tell you? If that multinational company, they outsource their network configuration management to Wipro or Infosys. Now, Wipro or Infosys who take that project, are they inside the organization, internal to the organization, or outside to the organization?
Outside.
Outside. So they come under public. They will be given public access. If the IT team of that MNC is using, then they use that as a private category. So while defining the protocol, you have options to provide public, read-only. And public means outsiders can read the components. Whereas for private, they give read-write permission. You're understanding? I want to give only read-only permission for the outsiders or the third-party vendors. Whereas for within the organization technical team, I want to give full control. So then I give public, read-write. I'm saying the opposite. Public, read-only, private, read-write permissions. Okay?
Okay.
You mean to say upgrade? Let me understand that question. SNMP version 2 to version 3, you want to upgrade. Yes, if you have the latest version of the router iOS or firmware, it is available. At the command level, you can specify the version you want. Let me see if I have the commands for, oh no, I have not mentioned the commands, I'm sorry. Okay. So basically at the time of enabling this protocol, you give SNMP version, there's a command, SNMP version 2, 2C, 3, you have options. Yeah, you can provide. If you give the command SNMP version 3 and you press enter key, it gives invalid command, means that particular router may not be supporting version 3. Okay. Coming to the last protocol of the day, that is NTP. So NTP is also a very important protocol. So I may be saying that everything that we touch upon is very important. Okay, so I don't know. It's a tough question for me also to ask. How many of you are having hand watch, not the phone? Don't see the phone time. I want to know if you are having a hand watch, and just can you ping me your time, exactly what time you see on your watch in the chat window? There may be 50 participants around in this session. And at least 5-10 people may be wearing a watch. Yeah, railway time 16:22. Mr. Venkatesh. Only one person having a hand watch. Unfortunately, I'm also not having. Yeah, another person, Mr. Kiran, 16:18. So you see, in a small group of 50 people, that is a different time. So what time I should end the session? What time I should start the session? Yes, nice. Thank you everybody. Bilal Rajmurthy sir, thank you. Yeah, so what time should I start? If we go by this watch and our train is supposed to start at 16:30, 16:30 railway time. No, what time we reach the railway station? See, yeah. So basically, why I ask you all this is to come to this protocol called NTP. Now you look into your phone and tell me what time you see on the phone. I would say 95 to 98% will be accurate, because all of us are using either BSNL or Airtel or Vodafone or something, and all of them use common. Very rarely you will find big difference. You see, previously the difference was between 2 to 3, minimum 3 to 4 minutes. Now hardly 1 minute difference between the various participants, isn't it? So this itself says that the service providers are using MTP protocol. Okay. So now let's dive into this protocol and see internally what it is and what it does. Okay. So NTP is also an open standard protocol like SNMP, HTTP, FTP, etc. So its function is to have a common time across all the network devices. We call that as time synchronization. NTP provides time synchronization between the computers. Means when I say computers in this statement, it refers to all the devices like routers, switches, firewalls, IP phones, everything over packet switched network. Basically, packet switched I'm referring to because we depend upon external source for this time, which we're going to see in a little while. And this protocol is operation since 1985, and it was developed by Mr. David from the University of Delaware. Okay, this is just to give you some information. So basically, the time protocol or NTP is used for time synchronization or having common time across the whole organization. So why? It helps the network engineers, administrators to have common time across various network devices. Basically, there are so many NTP servers providing the time, thousands of servers across the globe. And most importantly, how these servers get the correct time. You may ask a question, okay, server is giving us end users correct time, but how the servers are getting the time, correct time? How the Airtel is getting correct time, how Vodafone is getting correct time, how BSN is getting correct time? Because those servers in turn are connected to GPS tracking devices and highly precise atomic clocks. This is the source, main source. Either they are using GPS systems for a common time, or they are using atomic clocks connected to those servers. Most importantly, you have a server, important server. This server is connected with either atomic clocks or GPS controls. That gives common time for all the network devices. So basically all NTP servers, they match with the UTC, Universal Coordinated Universal Time, like GMT. Like normally we remember the time called GMT time, common reference point. So something similar lines, they call it as UTC. So basically they provide extreme precision, offer great accuracy on smaller networks to large networks, going down to single millisecond, means that much of accuracy, and over long periods, most importantly over the years. Suppose we have a watch, previously we are talking about battery operated watch. Once a battery is down, then the time will slowly come down. Like 1 minute is not equal to 1 minute. 1 minute may be equal to 1.5 minutes, 2 minutes sometimes. Once a battery is fully dead, it doesn't move at all, isn't it? So even millisecond difference also cannot be differentiated over a period of time. Okay. So that's the advantage of using these atomic clocks or GPS systems. So NTP does not account for time zone, means that this is left for the administrator to set. Suppose I am in the GMT 5.3, 5 hours 30 minutes plus 5.3, right? So that has to be set locally on the operating system. Okay. So that is not taken care by the NTP. NTP's job is to display correct time. Okay, let me quickly go to where do I get this? zone. Okay. Just go to the time. You just go to time. There will be an option called get network time. That option I just wanted to show you. Okay. So this is the hierarchy of time servers available globally. So if you see here, this is atomic clock. This is GPS system. So those are connected to this time server. These are called as time servers. Stratum 1, we're going to discuss about the stratum. If that is, this in turn is sharing the time to next level servers. And this in turn is sharing to next level servers. Okay, so mostly the ISPs maybe, if they have their own GPS system tracking, then they can be stratum 1. Synchronization of atomic or radio clock in local and global networks. It's just a picture to represent how NTP time is transferred. How does this server get? It gets from the source, main source. And it is over the network. You're sending this NTP because it's an NTP protocol, like HTTP protocol. It is transmitted over the networks, data networks. So the time is transmitted from stratum 1 servers to stratum 2, and then from stratum 2 to stratum 3. And those which are directly, you can see here, degree of separation. As the time moves from stratum 1 to stratum 2, stratum 2 to stratum 3, very slight variation in time happens. Okay. So the degree of separation from UTC source are defined as strata. Stratum 0 means reference clock. The main reference clock is called as stratum 0, which means in this picture, this is stratum 0. Very accurate. The moment you come to stratum 1 or stratum 2 and so on, very small difference will take. You can say accuracy is reduced with each additional degree of separation. From stratum 0 to stratum 1, it can be from millionth of a second. Just trying to say the time difference between stratum 0 and stratum 1 may be millionth of a second. When it comes from stratum 1 to stratum 2, again further 1 millionth of a second. Example. So the accuracy decreases as a stratum number increases. So why NTP is important for us is to see time. Everybody wants to have accurate time or not? What time we should get up, what time we should sleep, what time we should go to office, what time we should complete this work, what time we should take the bus, take the train, take the flight, So time is so important for us. Similarly is the case for banks, for example, banks. Why time is important for the bank? Suppose you go and deposit the money in the bank, they have to write a reference, right? On this date, on this time, this customer has deposited this amount. So if the time in his system is wrong, suppose in his server, the machine is having tomorrow's date, for example, just giving example. So you deposit it today and it will reflect in your account as it's deposited tomorrow. Is that good? You will lose 1 day of interest, right? Am I right? So time is very important. Yeah, we need to be very, very careful while setting up networks because it's all done by the designers, network designers. Before the network is in place, a lot of activity goes on. Like suppose you want to build a house, what do? You don't go to the market and buy cement, bricks, and sand and start constructing, right? So you have planned to build a house. First, you need to create a plan, then go to the government, get the approval, get the permission, then give this to a contractor, then the contractor will pay all that. So like that, suppose you want to have a network, then there's a lot of activity that happens behind. And that NTP is also an important component to introduce. Okay. So that is about the NTP protocol. So we have few minutes, we can take questions, doubts or questions. Okay, so atomic clock, frankly, I don't know how it looks like. I do have studied, I've seen the picture, but I don't know the internal functionality. You can just Google atomic clock, maybe you can get some pictures. Let me check if I can do that. Oh, no. I think this one, yeah. Building better atomic clock. This is how do atomic clock works. Probably this is more accurate. Applications of atomic clocks, no. Atomic clocks in space. I think this could be something closer. Looks like building better atomic clock. No, okay. So it's gone something. How to? Okay, so maybe this is giving us more technical information. How to build better atomic clocks, yeah? Yeah. Maybe if you have any questions about the redistribution also, we can spend time on that. Ali sir, anything? Yeah, okay. Redistribution of OSPF routes into EHRP. Okay. No. Okay, so coming back to this distribution, before redistribution, we did not have any routes. So before redistribution, we did not have, let's say, this particular routes. If you just see, these are the routes, right? 172.16.1.0 will not be available on this router, ENT remote. So when you look at the concept, two different protocols do not exchange the routes. They don't talk to each other. It's like I'm speaking French and you're speaking English. I will not be able to understand what you speak in English and you will not be able to understand what I speak in French, right? So two different protocols don't talk to each other unless we have another person who knows both the languages. Let's say this is the person translate. For example, if Prime Minister of India visits France or Germany, the Prime Minister or President of that country may not know English, for example. Let us say they don't know. But how do you communicate? So you'll have one person who is a translator who knows both the languages. So similarly, we must have, for any redistribution to happen, there must be one router which is running both the protocols. Only then it can translate from one routes of one protocol to another. So while redistributing from OSPF into EHRP, we have to ensure that, like I told you, the person from India is going to America. So he has to carry the US dollars because EHRP uses metrics called bandwidth, delay, load, reliability, MTU. So those are the parameters. So this is the routing table on E1, which is this left side router. This is the routing table on E2, which is having both OSPF routes as well as EHRP routes. Because this in the middle, it is talking to both protocols. Now, when it comes to remote router, which is having only EHRP routes. If you observe closely, we don't have 172 series IPs in this routing table. 172 series is not available because that's an OSPF protocol. Now, after configuring on the middle router, ENT2 router, telling EHRP protocol, I am giving you OSPF routes which are already available on that routers. For example, remember this is E2 router configuration. I'm going to show you the routing table of E2. So this is E2. It is having both OSPF and EHRP. So I'm going to tell ENT2 to send this 172.16 routes, these two routes, OSPF routes into EHRP. Where I'm telling EHRP protocol, I'm going to share with you the OSPF routes based on this particular command. Sorry. I'm telling EHRP protocol, redistribute OSPF because OSPF routes are already available in the E2 router. So those routes are being exchanged into OSPF protocol. which are now reflected on the remote router, that 172 series routers as external routes, means they have learned from a different protocol. And as also mentioned, the administrative distance of the redistributed routes for EIGRP will change. Whereas for other protocols, the AD value does not change.
Sir, unless both way redistribution is configured, communication is not possible, no, sir?
Exactly, you are right. We are only discussing about the concept. You are right, because if I am able to see this 172 route on this router, the user in this can send data to this 172, which means the one-way path is available, meaning the data will come from this computer to this router. Router will check in the routing table. There is a path available. It goes here. This router will forward to here. This will send it to the destination. The destination will send a packet reply back here, but this router don't have the route. For 192, 168, there is no route. So packet gets dropped here. For data communication to happen in this type of topology, must configure two-way redistribution. Without two-way redistribution, data is not possible to move from one network to another network.
But in a live situation, Realtel, what they are using, so they're mostly using BGP only, no? The BGP.
Sir, actually they use BGP and non-BGP. OSPF, I think they are already using OSPF in the core.
OSPF they are using in the core networks.
Correct, sir.
So that kind of redistribution also required in that?
100%, sir. Any ISP, any MPLS provider must do redistribution. Without redistribution, network cannot work.
Okay.
See, this is one end. If you took a small ISP also, redistribution is mandatory.
So tomorrow
they
we
cannot
have this.
Expect one company to use one protocol. Even in intranet case also, very rare we'll find big companies using one single protocol.
But now almost it is standardized, no? Everywhere for OSPF in MPLS. I think apart from OSPF, any other protocol is being used.
So if a company is using purely Cisco, there are some companies, they don't use any other product other than Cisco, whether it is router or switch or Wi-Fi or anything, they will use only Cisco product. I don't know for what reasons, but there are some companies will use only Juniper products. Some companies, they don't mind which product. They say, for me, this should work. So they will use a combination of products. So different companies use different IT policies. In that situation, they use EIGRP. If a company is using Cisco products, they mostly use EIGRP, but they can also use OSPF on that network and BGP. Yeah. The more, if in a service provider environment, within the organization, they use one protocol, while communicating with other ISPs, they use another protocol. Let's suppose Realtel has two different entities. One as an ISP, they are providing internet to the users or companies. Two as a service provider, connecting. I have 100 branches across the country, and I'm using Realtel as my backbone. It is only providing my branch-to-branch connectivity. So this as a service provider, two as an internet. So in both the cases, they have to use redistribution, minimum two different protocols. Because in my company, I am using EIGRP. So the EIGRP has to talk to Realtel. And then they in turn will send these routes into BGP, because they have to communicate with my remote branch offices. So they have to use BGP.
Okay.
It's an example to show that two different protocols are mandatory in big companies. Yes, sir. Ali sir, you were asking about tomorrow's session.
Yeah. Tomorrow, this as we have discussed, we have this L3 VPN and L2 VPN scheduled for tomorrow.
Yes, sir. I am just checking out this. Discussion on L2 can be done, sir. Practical, demonstration wise, I can, like how I showed today. In a similar way, I made one configuration. I have been given that. I don't know where I kept it. Sorry, yeah. The sheet, the schedule sheet for me for traffic. I'm sorry. Was given as route distinguisher, route target, L3 and L2 VPN. That's the topic.
Yeah.
But because to discuss about route distinguisher and route target individually, it hardly takes few minutes. So I'm going to include that in the configuration of L3 MPLS VPN.
A little bit of RD and RT was covered today, actually, in the morning session.
Oh, okay. So actually, that was my topic. Actually, yeah, when you're talking about VPNs, that component will come. It's not like I cannot say that, in this discussion, we have to use these parameters only. So basically, the moment we touch MPLS VPN,